I've been asked to do a few more implicit differentiation problems, and this is something that I think confuses a lot of people. So let's do a couple of more problems. And this is, I think there was a typo. I forgot the user that actually sent this, but I'm guessing this is what he intended. And if this isn't what he intended, this is something close, so it should give the idea. So the implicit function they gave was x squared minus 24xy plus 16y squared minus 400x minus 300y is equal to 0. So how do we do this? Well, we take the derivative of both sides with respect to x. I could write the derivative operator on both sides, but I think you know that at this point. So that's the next step. So let's do that, and I'll do it in blue. Blue. Okay, derivative of x squared with respect to x is 2x. And now let's see, it's going to be minus 24. I'm going to take the constant term out. So minus 24 times the derivative of xy. So what's the derivative of xy? We could use the product rule here. The derivative of the first term, x, well, that's just 1, right? So 1 is the derivative of x times the second expression, or you could say the second mini function or whatever, times y. And then plus the first expression, x, times the derivative of the second expression. Well, what's the derivative of y with respect to x? And this sometimes confuses people because it's so easy. Well, it's just dy dx, and instead of writing dy dx, I'm just going to write y prime here, just to get you used to a different type of notation. Although I prefer dy dx because you realize that you're using the chain rule. But anyway, x y prime, that's dy dx, plus, so we'll do the chain rule again. So let's take the derivative of this expression with respect to y first. So that's just 32y. But we're taking the derivative with respect to x. So we have to take the derivative of this with respect to y, which we did, and then multiply that times the derivative of y with respect to x, which is just dy dx, or y prime. Y prime. And then this with respect to x, well, that's just minus 400. And then what's the derivative of this with respect to x? Well, it's minus 300, and then times the derivative of y with respect to x, because we're doing the chain rule, right? Minus 300 is just the derivative of this with respect to y. And then, once I want to hit this point. Some people, when they learn this, just say, oh, whenever I take a derivative of y, I just take the derivative and I multiply by y prime. And that's right. That's essentially what you're doing. But I want you to understand that you're doing the chain rule when you do that. So you're taking the derivative with respect to y and then multiplying that times the derivative with respect to x, which we'll write as y prime now. And all of that is equal to 0. Now let's simplify this. So let's see, I get 2x minus 24y minus 24x y prime plus 32y y prime minus 400 minus 300 y prime is equal to 0. And let's switch colors. So let's separate all the y prime terms out. So let's see. Let's see what are the y prime terms. We have this term has a y prime in it. We have this term has a y prime in it. And we have this term has a y prime in it. So we can write these. Let's do the positive one first. So 32y. So this is the same thing as y prime times 32y minus 24x minus 300. Those are all the y prime terms, and then we're left with just the regular terms. So then plus 2x minus 24y minus 400 is equal to 0. I just rearranged it and took out the y prime out of this, and this term. Let's take all of these to the other side of the equation. Now, essentially what I want to do is get all the terms that don't have the y prime onto the right-hand side and then divide by this, and then we would have solved the equation. And let's see. So we get y prime times, and this is, you could also write, the derivative with respect to x, or dy dx. In general, even though it takes more time, I like to normally write dy dx because you remember I'm taking the derivative with respect to x. Y prime, I don't know. You might be taking the derivative with respect to who knows what. So let's see. 32y minus 24x minus 300 is equal to, put all of these on the right hand side, so you get, I'll switch the order, I like to put the positive numbers first. 24y minus 2x plus 400, right? And then divide both sides by this, and I'll do it in a different color because we're almost at the answer, and we get y prime, or the derivative with respect to x, is equal to this thing, 24y minus 2x plus 400, all of that over this thing, 32y minus 24x minus 300. And let's see, we could at least, it looks like, well, we could, everything's divisible by 2, so we could divide the numerator and the denominator by 2, and you get 12y minus x plus 200 over 16y minus 12x minus 150. And if I didn't make a careless mistake, that's the answer. The derivative of y with respect to x at any time is this expression that has y's and x in it. And that's cool because this is a fairly convoluted implicit function, but we can figure out the slope of it at any point because we know the derivative. Let's do the next one. This one looks simpler. X minus y squared is equal to 8 times y minus 6. All right, so let's just take the derivative with respect to x of both sides, and I'll use the dy dx notation this time. So let's first use the chain rule. Let's take the derivative of the inside. So what's the derivative of the inside function? It is, well, we could do it either way. Let's do it the other way. I always do inside and out. But let's take the derivative of this entire expression with respect to x minus y. Well, that is 2 times x minus y. And then it's going to be that times the derivative of x minus y with respect to x. So what's the derivative of x minus y with respect to x? Well, the derivative of x with respect to x is just 1. And what's the derivative of, well, we could say minus y with respect to x. Well, it's just minus dy dx. You could say the derivative of y with respect to y is, or the derivative of minus y with respect to y is minus 1, and then by the chain rule, multiply that times the derivative of y with respect to x. Either way, I think you get the point, hopefully. So that's the derivative of the left-hand side. And now what's the derivative of the right-hand side? Well, we could do the chain rule or whatever, but this is the same thing as 8y minus 48, right? So this we could rewrite this as 8y minus 48. And so if you take the derivative of this with respect to x, this is the constant doesn't contribute. So what's the derivative of 8y with respect to x? Well, it's the derivative of 8y with respect to y, which is just 8. And by the chain rule, times the derivative of 8y with respect to y, times the derivative of y with respect to x. And now we just solve for dy dx. So let's see, you get, and I will do a different color now, 2x minus 2y times 1 minus dy dx is equal to 8 dy dx. And then what can we do? We can distribute this out. So 2x times this whole thing. So 2x minus 2x dy dx, right? That times that, and then that times that, and then this times this. So minus 2y, and then minus minus, so plus 2y dy dx. And then let's take this, because I want to put all the dy dx terms on the same side. So let's subtract this from both sides of this equation. So then we get minus 8 dy dx is equal to 0. And then the next step, let's just separate out all the dy dx terms. So that's a dy dx term. That's one. That's one. They're easier to spot than when you write y prime. So let's see. So if we take those together and take out the dy dx, we get dy, the derivative of y with respect to x, times, let's see, are any of them positive? Let's see, I'll put that one first. 2y minus 2x, right? That's this one, minus 8, and then plus 2x minus 2y is equal to 0. Let's put these onto the right-hand side of the equation. We're almost there. dy dx times 2y minus 2x minus 8 is equal to 2y minus 2x. I just took those, put on the right-hand side. And now divide both sides by this, and we are done. dy dx excuse me, is equal to 2y minus 2x, all of that over 2y minus 2x minus 8. And once again, we can divide the numerator and the denominator by 2. So we're left with y minus x over y minus x minus 8. And we're done. Hopefully you found that helpful.